So in our previous class, we have seen the instruction set of 8051 can be classified in four categories. First is data transfer instructions, where we have studied move, move C, move X, push pop operations. There is one more operation, exchange, which we'll study in due course of time. You can put a question mark about that. We would see that. The others are arithmetic instructions, which I asked you to study: addition, multiplication, subtraction, division, increment, decrement. And there are a few logical instructions like AND or XOR, rotate. And there are a few bit manipulation instructions like you want to set or make any bit 1, or you want to make any bit 0, that is called clear. If you want to make any bit 1, then it is called set B or 1. So we'll see these instructions when we write codes. There is one more important category of codes are program flow control instructions. This type of instructions, what happens, we change the flow of the our program. Like for example, if we are executing these sets of instructions, and then we want at certain point that we should jump to some other set of instructions, then we use jump command, and then it will perform these set of instructions. Similarly, there is call, which is also known as subroutine calling, and this is a loop, which we'll see. But my question is, if you just write any of these commands, and then, for example, you write this command, and your objective is to transfer the immediate data 08F to the R2 register. And R2 register, we know that lies, since we are not mentioning any bank, so we assume that this is by default we are using bank 0. So this is your R2, and your objective is that you want to write 08H in this register. This is an 8-bit register. So in 8-bit register, you want to store this value. This is your objective. So you would write this command, and in SM, since you are instructing your controller in assembly language, then you would need one assembler. You would definitely need one assembler to convert this assembly language instruction to binary or the machine language instruction, which is understood by your microcontroller. And then once you perform this operation, then you will execute, when you run this code, then this function of transferring 08 to R2 will happen. So step 1, what would be your step 1? Step 1 is you write command in assembly language, and you assemble it using assembler, which will convert it to equivalent machine language code. So how would you know what is the equivalent machine language code for move R208H? So this belongs to the category of instruction where you are using register addressing for the memory and direct and immediate addressing for the data. So you are transferring your immediate data to some register. So for this, what we do, we go to the manual which is provided by the 8051. This is the Intel 8051 instruction set. Here you can see you have all the operations which are performed, which are supported by this 8051 microcontroller, like arithmetic operations, logical operations, data transfer operations. As one second. I think my screen is not visible. No, my screen is not visible to you. Yeah, so now I think my screen is visible. So this is the instruction manual which you can find in I think Moodle. Yeah, in Moodle we have already provided this instruction set. So this is the set of all the instructions which is supported by Intel 805. So this is the arithmetic operations. These are the logical operations. This is the data transfer operations, and these are the bit manipulation operations. So these are, I mean, when we write the instruction in assembly language, we also call it mnemonic, just a term, and program branching, or what we have discussed, right? Program branching, flow control instructions. So you can find that how you can just this is your home exercise, that to see how many arithmetic operations are supported by 8051, how many logical operations are supported by 8051, how many data transfer operations are supported by 8051. So this is your home exercise. You do it by reading this manual. After reading this manual, you can do that. Yeah. So our original question was, first we write any such instruction. We can write any such instruction, or we can write set of such instructions, right? Sequence of such instructions. So we started that what would happen when you write move R2, 08H, and then you use assembler, which will convert it to equivalent machine level, machine format, right? Machine coding, machine code, or binary code. So we want to see what is the equivalent binary code for move R2, comma, immediate data. So if we go to this line, we see, so here equivalent opcode or the equivalent binary code is given to you. So it is move R2, comma, hash data is 7A. If you see in hex, it is 7A. Move R2, comma, hashtag data is 7A. So equivalent machine binary code is 7A for this move R2. And then whatever immediate data you provide, you write here. So this is a 1 byte, this is another byte. So assembler, what would assembler do? It will, when you assemble this code, assemble this instruction, it will go to program memory, that is your ROM, and it will write this to 2 consecutive locations. And these 2 consecutive locations are by default, if you have not written anything, starts from 000. So first, in the first location, you will write, your assembler will write 0, 1, 1, 1, and A means 10 in binary format. So this. And in the next position, what would be written? 0, 0, 0, 0, 1, 0, 0, 0. So this is your program memory or ROM. So now what you have done, you have assembled your program, you have successfully converted your assembly language, a mnemonic, to the binary code which your machine understands. Next, what would happen? Next, you will run. Now you have successfully converted your source file to object file, source file to object file, you can see. And you have also written all of this to ROM. Next, what would happen? As I told you, now you will execute. Next, you have written your program to your memory. Now your controller will fetch, decode, and then execute this. Correct? Because your machine understands this machine like binary codes. So next, when you run this code, now you have code stored in your memory. Now, when you run this code, it will first fetch the code and then decode it and execute it. So let's first understand first step by using Etcd. So our code is move R2, comma, hashtag 08H. So as you can see, as I told you, that when you assemble it, it will write, we are here in the code memory. So in code memory, I told you 000, it will write 7A, and at the code memory 001, it will write 08. So this is what we have discussed. Step 1 is complete. Now we want to run this code. Step 2, right? So what would we do? We'll use step or run. So we'll use step. What it will do, it will transfer the value of R2 to transfer value 08 to R2, and you can see that R2 in R2 08 is written. Right? One more thing happened, that the value of the program counter will also change. What is your program counter? Program counter is a register, is a special function register. I wrote somewhere the definition. 1 second. Program counter is a special function register which contains the instruction address of the next instruction to be fetched. So during step 2, during step 2, from where we should fetch our instruction, the program's counter will show you the address. Initially, by default, 000 is the address from where your controller will fetch the instruction, and there you have written 7A. There you have written 7A. So 7A, by reading 7A, it will decode. Microcontroller knows, if you see your instruction guide, where it is written that 7A means move R2 comma some data. So here from this, your microcontroller will understand that I have to move some data to R2, and which data I have to move will I have to see from the second. I have to see from the second consecutive register. So it will see, as soon as it sees 7A, it will know that from the next address I will get the data which I want to move to R2. But as I told you, the value of the program counter will also change. But by what amount? It would depend on the number, the bytes which is allocated to this instruction. So how many bytes are allocated? How many addresses are allocated to it? 2, right? If you remember. Program counter is this register. So this is your ROM, where you have stored your 7A and 08. And this is your program counter. So initially program counter was this. So now you see to your instruction manual, move R2 hashtag data is a 2-byte instruction. So since as soon as it sees 7A, your controller note it is a 2-byte instruction, so it will move the program counter value to 001 plus 2, because it knows that this type of instruction would take 2 consecutive location, and since if there is next some other type of instruction, it would be after the 2 location. So it will change the program counter value by 2. So what would happen for this operation, for this particular operation? Of course, the value of PC would depend on the number of instructions, number of bytes allocated to these instructions. So move R2 hashtag data is allocated 2 bytes. So what would happen? First, the program counter value will be increased by 2. And then at R2, R8 will be transferred. So I think it would help you just look at this video, and we'll discuss it in our class.